This is an IGCSE Edexcel chemistry paper. It's a 2C paper, so for triple candidates from June 22. There's your all-important periodic table. This question is about gases in the atmosphere. The box gives the names of some gases. Choose gases from the box to answer these questions. Identify the least reactive gas in the atmosphere. So we need a group 0 element. So we're looking down this column and it's argon. Identify the most abundant gas in the atmosphere. So we've got the largest quantity of nitrogen gas at around 78% of our atmosphere. Identify the gas that's not normally found in the atmosphere. So we find these things, definitely not hydrogen. Remember, that's very flammable. State an environmental problem caused by increasing amounts of carbon dioxide in the atmosphere. It's all everyone's talking about. It is global warming. Describe a test for carbon dioxide. Add gas to lime water. And remember, it should turn cloudy or milky. The diagram shows two pieces of apparatus, X and Y. Give the name of each piece of apparatus. That first one is a measuring cylinder. The second one is a glass pipette. Not one of those rubbishy plastic ones that you squeeze. In a titration, a student adds 25 centimetres cubed of barium hydroxide solution to a conical flask. Why is it better to use Y compared with X? Hopefully you know the glass pipette is way more precise than a measuring cylinder. The student uses methyl orange indicator in the titration. State the colour of methyl orange in barium hydroxide solution. Remember, this is alkali, so it will be yellow. Give a reason why universal indicator is not suitable for use in a titration. Remember, you want a very definite endpoint, so it's the sharp change where it goes from one colour to another. The problem with universal indicator is that it has a range of colours which go from red in very acidic solution to blue in very alkaline. The student adds some dilute nitric acid to burette and does the titration. The equation is this. The student finds that 25.5 centimetres cubed of nitric acid with this concentration neutralises 25 centimetres cubed of barium hydroxide. Calculate the concentration of barium hydroxide. Right, this is how we're going to do this. This is a nice straightforward titration calculation. Let's get ourselves set up. Here's our formula triangle, which states that number of moles is concentration times volume. We're going to use a table listing that formula triangle down the side. Put an X next to what we're after, so it's the concentration of barium hydroxide. And then insert all the numbers that you've been given in the question. So we know that we have 21.5 centimetres cubed of nitric acid. Remember, we need that in decimeters cubed, so in order to do that, we divide that number by 1,000. We know that the concentration is 0.6, and our volume of barium hydroxide is 25. Again, get that into decimeters cubed. This means we're ready to find the number of moles. So number of moles is given by concentration times volume, so the number of moles of nitric acid is these two numbers multiplied by each other. 0.0129. Check the mole connection, it's 2 to 1. So we can take this number and put it there, but only if we divide it by 2. Our last step is to find X, the concentration. We do that by doing number of moles divided by volume to get 0.258. State why sulfuric acid would not be a suitable acid to use in this titration. Just have a look at this salt that we make. It's a nitrate, which means it's soluble. If you were to use sulfuric acid, it would make barium sulfate, which is an insoluble salt. Which we don't want. We don't want that solid forming in that conical flask. This question is about group 7, the halogens. Which halogen has the palest colour? So if we go back up here, a bit hard because it's on the side. These are the halogens. Remember, they get darker in colour as you descend the group, and they also increase their melting point. So you'll find solids down here and gases up here. So the palest colour will be at the top of that group, which means it's fluorine. Which halogen is a solid at room temperature? Astatine, because that sits at the bottom of the group, towards the bottom. The table shows the electronic configurations of a fluorine atom and a chlorine atom. Explain the relative reactivities of fluorine and chlorine using the information shown. So notice the number of electron shells. Fluorine only has 2, chlorine has 7. So when you go to add that extra electron, which remember is all to do with reactivity, it's going to be much easier to gain an electron for fluorine because it's a smaller atom, which means the positive charge from the nucleus will be far more attractive for that electron. So we'll write fluorine is more reactive than chlorine because fluorine is smaller, which means the outer electrons are closer to the nucleus and are more tightly attracted. It's easier for fluorine to gain an electron. Lithium reacts with chlorine to form lithium chloride. Write a chemical equation for this reaction. So it's lithium plus chlorine. Remember, it's a diatomic molecule. Let's look at our ions. Luckily, they are going to balance each other out. Get it balanced. Describe test to show that the product of the reaction is lithium chloride. Wow, 5 marks. Okay, let's first of all prove that we have lithium present. So use a flame test. And let's outline a flame test. We're going to hold sample in roaring blue flame of Bunsen burner. And you must learn these colours. And it should turn crimson red in the presence of lithium. Now we're testing for the chloride ion. So remember, you need to add nitric acid and silver nitrate. You must learn these chemical tests, or the tests for positive and negative ion tests. You will see a white precipitate formed and that's how you get your 5 marks. Question 4. This question is about magnesium compounds. Magnesium burns in oxygen to form magnesium oxide. State 2 observations. You get a bright white, light, seen, and then left over you have a white, solid. The diagram shows the electronic configurations of a magnesium atom and an oxygen atom. Describe the changes in the electronic configuration when magnesium reacts with oxygen to form MgO. It's up to you if you want to write it or just draw an ionic bonding diagram. I'm going to draw. Let's label. So we've got magnesium, we've got oxygen. So remember, magnesium is going to lose these outer electrons and they're going to get transferred to make sure that both the magnesium and the oxygen have a full outer shell. Now, because magnesium has lost 2 electrons, they have a negative charge, which means it will be 2+. Oxygen has gained 2 electrons from the magnesium, which is why it's a 2- charge. Magnesium can be produced by the electrolysis of molten magnesium chloride. State why magnesium cannot be produced by heating magnesium oxide with carbon. This is all to do with the reactivity, because magnesium is more reactive than carbon. Explain the different ways that magnesium chloride conduct electricity. So magnesium is a metal and conducts when solid and molten. And we need to say why, because it has delocalized electrons which are free to move. Magnesium chloride, being a metal and a non-metal, is a giant ionic structure Remember that they can't conduct when solid, but can when molten, because those all-important ions are now free to move. During the electrolysis of molten magnesium chloride, magnesium is formed at the negative electrode. State why this is a reduction reaction. Remember oil rig. Oxidation is loss of electrons, reduction is gain. We have gained 2 electrons. Write an ionic half equation for the formation of chlorine at the positive electrode. So we have Cl- having to form diatomic Cl2. So make sure you get that balance first of all. And then in order to do that, it needs to lose 2 electrons. So you can write it like that. Or, and you'll probably see it more written like this on the mark scheme, both is fine. You can write it like that. An organic compound has this percentage composition by mass. Show that the empirical formula is this. So in order to do empirical formulae, list the elements. Then we do mass, MR, number of moles, set up our formula triangle, which states that mass is MR times number of moles. In terms of writing the mass, don't get confused, it is just these numbers here, even though they're percentages, but they're all relative to each other, which is why we can write them like this. Use your periodic table to find the MR. Then to find the number of moles, we do mass divided by MR. So that's 40 divided by 12, 6.7 divided by 1, 53.3 divided by 16. And then look at these 3 numbers and divide all by the smallest number. So our ratio becomes 1 to 2 to 1. so CH2O, which is what we're after. Draw the structural formula of a compound with the molecular formula C2H4O2. So the structural formula is when you show the layout of these elements. So we need 2 carbons. We've got a lot of H's and 2 O's. So the fact that it's 2 O's hopefully is indicating that we have a carboxylic acid, which remember looks like this. But that's the displayed formula. So we need to get that into a structural formula. So just write it out as you see it. So that's actually the answer here, the structural formula. And that is ethanoic acid. Methanoic acid reacts with sodium carbonate solution to give 3 products. Complete the equation for this reaction. So we are going to make sodium methanoate. So just have a look at these ions here. That's the effective ion you have for the methanoic acid. Here's your carbonate ions and your sodium ions. So to write sodium methanoate, you're basically putting these 2 ions here together. So it becomes HCOONA. And then you just get carbon dioxide and water as your byproducts. Make sure it's balanced. State what you'd observe in this reaction. You'd see fizzing because of the bubbles of CO2 given off. Methanoic acid also reacts with propanol to form an ester. Give the name of the ester that forms. So the ester's name, first bit comes from the alcohol, so prop. Second bit comes from the carboxylic acid. So it is propyl methanoate. State what is meant by this symbol. Remember that means it's reversible. When this reaction occurs in a sealed container, the reaction can reach a dynamic equilibrium. Give 1 characteristic. Remember it's the forward and reverse reactions occur at the same rate. A polyester forms when butane dioic acid reacts with ethane diol. The diagram shows the repeat unit of the polyester that forms. Give the name of this type of polymerization. Because you're constantly losing water molecules throughout, remember that means it's a condensation reaction. Draw the structural formulae of the 2 monomers used to make this polyester. So let's work out where we lost our water molecules. It's going to be here. So there's your alcohol end. There's your carboxylic acid end. So basically complete that functional group of the carboxylic acid. So there's the COOH, and then just write the rest out as you see it. Make sure it's nice and symmetrical, and then we'll complete this alcohol over here. Notice they've given you lots of help by drawing that out already. Titanium is an important metal in industry. Titanium dioxide can be converted into titanium in 2 stages. Calculate the volume in decimeters cubed of chlorine gas needed to react completely with 20 tons. Give your answer in standard form. Okay, so we're going to steal this equation. Right, we need to find the number of moles of chlorine gas. Then we write mass, MR, number of moles. We're after the number of moles of chlorine gas, so we can do the final stage that will enable us to find the volume of it. What is our mass of titanium dioxide? Well, it's 20 tons, so 20 times 10 to the 6 to get those units sorted. The MR we've been told is 80. So our number of moles is 2.5 times 10 to the 5. What about our number of moles of chlorine? Check the mole connection. It's 1 to 2. So you just want to double that number. So it becomes 5 times 10 to the 5. And then lastly, the volume is the number of moles times 24, because they've told us that 1 mole of any gas occupies 24 decimeters cubed. So let's sub in the number of moles we have. So here's our answer once we've used our calculator, and then get it into standard form. So count it 1, 2, 3, 4, 5, 6, 7. In stage 2, titanium 4 chloride vapour is passed through molten magnesium in a container filled with argon. Explain why the container is filled with argon rather than air, because argon is unreactive. Remember, it's a group 0 element and therefore will not react with magnesium. Aeroplanes are made of an alloy containing aluminium and titanium. Explain why the alloy is stronger than pure titanium metal. So the thing about having an alloy is because you've got multiple elements, it means that the atoms will be different sizes, which means that will distort the layers, meaning that the layers won't slide over each other as easily, therefore meaning that your metal's harder. Question 7. A student uses this apparatus to find the heat energy supplied by liquid fuel. The student burns some fuel to heat the water in a copper container and measures the change in temperature. The student notices the bottom of the container turns black. Give the name of the black substance. That's formed by incomplete combustion. It's solid carbon known as soot. In one experiment, the student burns 0.29 grams of ethanol. The student calculates that the heat energy absorbed by the water is this. Show that the results of this experiment give an approximate variable for the enthalpy of combustion of this. So we need to start by finding the number of moles of ethanol. So that's mass divided by MR. We've been told that that's 0.92. Our MR is 46. So that's 0.02 moles. And then our delta H is the heat energy divided by the number of moles. Just be doubly careful with those units. We're fine because they're the same. But sub in the values you've been given. And then the reason why delta H is negative is simply because it's an exothermic reaction, because the temperature's gone up and a fuel's been burnt. The data book value of delta H is minus 1,367. Give 2 reasons why the student's value is much lower than the data book value. That's due to heat loss to the surroundings. As well as that inefficiency brought about by incomplete combustion. So that means burning in an insufficient quantity of oxygen. The equation shows the combustion of methane. This is the equation showing the displayed formula. Calculate the bond energy of the CH bond using information from the equation and table. So we're being asked about these bonds here. So the way you do this is you do bonds broken minus bonds formed. So let's list those bonds broken. It's 4 lots of CH bonds. Count them. 2, 3, 4. We don't know what that CH bond is. That's what we're being asked to find, so I'm putting an X. 2 lots of O double bond O bonds. So it's 996 plus 4X. What about our bonds formed? It's 2 lots of O double bond C. And it's 4 lots of OH bonds. So the equation is bonds broken minus bonds formed equals delta H. So let's just put that all together. Equals, we've been given delta H minus 890. So now just solve it. 996 minus 3462 minus 2466 plus 4x equals minus 890. To get 4x by itself, you want to add 2466 to both sides. And then the last thing you do is divide that number by 4 to find the value of that CH bond. And that's how you get your 4 marks. Complete the energy level diagram to show the products in delta H. So we're looking here. It's a combustion reaction, which means it's an exothermic reaction. So that means those products need to sit at a lower energy compared with the reactants. So you can eyeball it, but it's somewhere around here. So there are products and delta H is negative. So we just draw a line between those two energy levels.